so we're going to continue with these harder examples. So this one up here, number 4. A 275 metre radio mast is 1.7 kilometres from a school. Now, here's your radio mast. It's a tall thing, starts at the ground and goes up and it sends radio signals to places. So they've said it's 275 metres. That's its height. Now, it says that the radio mast itself is 1.7 kilometres away from the school. So it would be from the bottom of the radio mast where it is on the ground compared to the school. They are 1.7 kilometres apart. Now, at the moment you can't do anything with this because they're in different units, right? This is in metres, this is in kilometres. So we're going to change this into metres before we start. So going to a smaller unit, we times by 1,000 per kilo, and that should give you 1,700 metres. So we are going to use the two things in metres for this question. Now, it says that we're finding the angle of elevation of the top of the mast. Well, here's the top of the mast. Angle of elevation means you must be standing down here, looking this way. You want to look up, so your angle of elevation is in here. That's what we're trying to find. They haven't given it to us, so we're going to put a theta there. Okay, so now we're going to sub in. This is our opposite side. This is our adjacent. So we're going to go tan theta equals opposite over adjacent. Tan theta equals 275 over 1,700, the two things in metres. Then, to get theta by itself, we're going to get rid of tan by coming to the other side and doing inverse tan of 275 over 1,700. Put it in your calculator and the answer will come up like this. That answer is in degrees for the D on the top of your screen on your calculator. We're going to the nearest degree, so we don't need to be pressing the degrees, minutes, seconds button. Just leave it as it is and round to the nearest whole number, 9 degrees. Okay, looking at the next one. We have a monument, 24 metres high. Here it is, 24 metres high. It's going to cast a shadow 20 metres long. Okay, so what happens when the sun hits the top of that building? It creates a shadow as that ray of sun hits the top and falls down to the ground. That's what creates the shadow. So 24 metres high building creates a 20 metre long shadow on the ground. We're calculating the angle of elevation. Again, we're looking up, so we must be here. Normal line of sight is across here. We're looking up at the sun, so it's the angle that your eye or head moves through to look up. And again, we're looking for the angle. They have not given it to us this time. So again, labelling your sides, opposite and adjacent. Tan theta equals L over A. Tan theta equals 24 over 20. Get rid of your tan. Inverse tan on the other side of 24 over 20. And your calculator will give you 50.19442891 degrees. You're rounding off to the nearest degree. So we'll go to the nearest whole number of degrees, and that's 50 degrees. Now the harder questions are things like this one, so let's have a look at it. So we have a flagpole mounted on top of a tall building. This actually happens in Parliament House in Canberra. It's got a building itself, and then right on the top they've got a really high flagpole. You can actually find out how tall that flagpole is in Canberra, but you don't need to actually get up there to measure it. All right, people can do it from the ground, and I'll explain that to you in a minute. Okay, so here's your building, and then on top of it, you've got your flagpole. It says at a distance of 250 metres from the base of the building. Here's the base of the building at the bottom of the building. 250 metres away from that, so we're at 250 metres on the ground. We have angles of elevation. That's what we're finding the height of the flagpole. I'll get to that in a minute. The angles of elevation of the bottom and top of the flagpole are 38 degrees and 40 degrees respectively. Respectively means in the order that they've given it to you. So they said bottom first, so that's the first angle. They said top second, so that's the second angle. Okay, so what they mean is you're standing down here. Your normal eyesight is across here. The first thing we're looking at, they said, was the bottom of the flagpole. So your eye or your head moves through this angle to focus on the bottom of the flagpole, which is here. Now that angle, they told you, was 38 degrees. Then, when you decided to focus on the top of the flagpole, your eye or your head moves through that angle to focus on the top of the flagpole. And they told you that that angle was 40 degrees. Now, that's our diagram so far. They've asked you to calculate the height of the flagpole, which is just that little part over there. Now, it's very tempting. A lot of boys just go, right, 40 degrees, 38 degrees, that little angle must be 2 degrees. Yes, it is. But that's not going to do you any good because that 2 degrees is in a triangle that's not right angled. It's in this skinny little thing here. That's not a right angled triangle and it's useless to you. All our work has to be concentrated on right angled triangles. And we have 2 right angled triangles in this diagram. This is one. And then we have the really big triangle. That's your other one. So we can work in those 2 right angled triangles to get this question out. Okay, so I'm just going to draw each triangle so you can see what I'm working on here. So the first triangle, just turn this around a bit. The first triangle is this smaller one that we're looking at here. So it's 250 metres here. We've got 38 degrees, and that's it. Now, if you look back at your original diagram, if we're going to find that, that's a little vertical side there. We need to concentrate on the verticals. So I'm going to find this, and I'm going to call it A, because it's the first thing I'm doing, so just call it A. All right, so let's label the sides. This is opposite, this is adjacent, and we're going to use tan and work this out. So tan theta equals O over A, tan 38 degrees equals A over 250. We want to get the A by itself, so we're getting rid of divided by 250. So let's come over here and do the opposite. Times by 250. And then we're going to get our answer off the calculator and we are not rounding. We're writing the whole answer down, otherwise it will throw everything out at the end. So we're going to do 250 times tan 38 and we get this. Okay, so that's that part done. And then we're going to look at the other right angled triangle. So that's the bigger one. So that's the really big one. And we're going to mark on everything we've got there. So we've got a 40 degrees here. We've still got our 250 there. And I'm going to call this B because it's the second thing I'm doing. And now we're going to find B. So we've got an opposite side and an adjacent side, and again we're finding tan. We're using tan. Tan theta equals O over A, tan 40 degrees equals B over 250. So we want to get the B by itself first. Get rid of the divided by 250. Times by 250 over on the other side. And now we're going to our calculator. So we're typing in 250 times tan 40 and write down your answer. No rounding. Alright, so we've got our 2 vertical sides. So if you come back to the original diagram, A. Sorry, wrong spot. This is what we call A, this bit here. And this is what we call B. So you can see what we've done. We found a vertical side here from the small triangle. We found a vertical side from the big triangle. So to find this little vertical side, we just do B minus A and we'll get what we need. Okay, so then we've got from there, and now we go to our calculator to put all of that in. Now I've still got the 209 on my calculator from before, so I'm going to leave that there and just subtract the other one. And we get this answer. And once you've got to your answer, then you can do your rounding. So they want 1 decimal place. So now we're going to do our rounding to 1 decimal place. That's a 5, so the one before it goes up by 1. And it's in metres. So the answer for your height is 14.5 metres for the flagpole. So that's actually what happens. They don't get up there to measure the height of the flagpole if they want the height of it. They actually send people in that have got odometers and clinometers and equipment where they can measure angles. All right, so when they do that, they just set the thing on, and it tells you the angle. They just line it up like we're doing when we're focusing on something. It tells them the angle. They do their trigonometry and they work out the height of the flagpole. They don't need to get up there to measure it. Okay, so you're going to have a go at these questions for homework. Make sure you draw the diagram carefully and show all your working.